Hi everyone, this is Dr. Bitla Venu. In our today's session, we will discuss projections of points and lines. In my last session, we have discussed regarding the front view, side view, and top view for a given engineering components we have seen. In my last three sessions also, we have seen how to draw the projections of orthographic projections for the given engineering components. In this session, we will see the projections of points, lines. When we place the points and lines in different coordinates, we will discuss in this session. Then, whenever we want to draw the orthographic projections of points, lines, and planes, and as well as the solids, we require some data. So the data is that the description or the definition of the object. The description means the size of the object, or for example, if we are drawing the orthographic projection of a line, we require the description, that means the length of the line. If we are drawing the orthographic projections of a point, we require the data like from which distance the point is located uh, with respect to the planes, reference planes. So in turn, we can say that the object must be well defined to draw the orthographic projections of points, lines, or planes, as well as the solids. Basically, we require the object data. The object must be well defined to draw the orthographic projections of the points, lines, and planes, and as well as the solids. The second one, the second parameter that we consider is the observer. Always observer is perpendicular to the respective reference plane. That means the observer must be perpendicular to the reference plane on which we are going to project. This is what the one more assumption that we need to consider while drawing the orthographic projections. Then the location of the object is very, very important. Like the position means the position with respect to the horizontal and as well as the vertical plane is very, very important to draw the orthographic projections of the point, lines, planes, and as well as the solids. So object must be well defined. Then the observer is always perpendicular to the respective reference plane. Then the location of the object must be required to draw the orthographic projections of the points, lines, planes, and the solids. So, to draw the projections of any object, one must have the information like the object, observer, and location of the object. These three information must be required. The terms used in while drawing the orthographic projections of these are the above and below with respect to HP. These are the terms that we are going to use in this slideshow. That means the component or the object is above or below to the HP. Then we may also use in front and behind with respect to VP, vertical plane, HP. Here HP means horizontal plane, VP means vertical plane. These are the terms that we are going to use in this slideshow. Above and below with respect to HP, in front and behind with respect to VP. These are the terms that we use in this slideshow. So from four quadrants, objects can be placed in any one of these four quadrants, right? The objects can be placed in any of the four quadrants. When we place the object in any of the four quadrants, we need to draw the orthographic projection. Then it is interesting to learn the effect on the positions of the views, front view and top view of the object with respect to XY line. That means where all the planes will meet, we are going to assume as XY line. First quadrant, second quadrant, that means horizontal, vertical plane is going to meet at certain location. So that location we are going to assume as XY line. So that also we need to consider. So let me move further to see what exactly some notations that I am going to use in this slideshow. So the notation is that object, point A, point I am going to, actual point I am going to notate, I'm going to use or indicate as capital A. Then if I am using a line, if I am drawing the projections for the line, the end points I am going to indicate as AB, the line AB. Line I am assuming as AB. The point I am assuming as capital A, line I am assuming as AB. The object can be point A or line AB. Then its top view, that means point top view, I am going to use the notation small a. Then line top view I'm going to indicate as AB. Then point front view I'm going to use as A dash. Then line front view I'm going to indicate as A dash B dash in this slideshow. Then it's a side view. Point A side view I'm going to indicate as A double dash. Then line front view, side view I'm going to use as A double dash B double dash. That means top view without any dashes, front view we have dashes, side view we have double dashes like this. A B, A dash B dash for the front view, and A dash B dash for the side view like this. A double dash, A double dash B double dash. Then let me move further to see. Then take the vertical plane, horizontal plane, then XY line, and this will be our first quadrant, then second quadrant, third and fourth quadrant. Let me take a component. Our observer is located, observer is observing by standing in front of the vertical plane like this, which is in first quadrant. Then when we observe, when the observer is standing in front of the vertical plane in the first quadrant, the front view will come on the vertical plane like this. The front view of the object will be projected onto the vertical plane like this. Then when you see from the left side view like this, the projections will look like this. Okay, so we have XY line exactly. All the quadrants will meet at this location, that is XY line. It looks like a point when you see from this direction. Then the vertical plane will also looks like a vertical line, horizontal line as it is. HP will looks like a horizontal line. When the observer is in the first quadrant, then this will be your second quadrant, third quadrant, and fourth quadrant like this. Now, I'm going to place a point in the first quadrant like this. This is the first quadrant, of course. Then I'm placing a point in the first quadrant. Then when you see from perpendicular to the vertical plane like this, the point will be projected onto the vertical plane exactly like this. When you see, which is when perpendicular to the vertical plane, as I told in our first slide, the observer must be perpendicular to the reference plane. But in this case, the observer is perpendicular to the reference plane here, vertical plane. When the observer observes from here, the point projection, the point will be projected onto the vertical plane like this. Then when the observer, so the front view I'm indicating as A dash, as I said with you, then the top view of this point will be projected onto the horizontal plane like this, and this will be indicated as A. But while drawing, it will not be possible to draw the projection or the top view of this point, so that I am rotating horizontal plane 90 degrees in clockwise direction like this, so that to indicate or to represent clearly with respect to xy line, which is exactly at this location. The xy line is at which the vertical plane and horizontal plane is intersecting. So with respect to xy line, I am rotating horizontal plane in clockwise direction to 90 degrees. So the point is, the projected point is certain distance above the HP, certain distance in front of VP. So when I rotate the horizontal plane 90 degrees, which coincides with the vertical plane, that means the point is certain distance above the HP and certain distance below the VP like this, below the HP like this. So the point which is in front of VP will become below the XY line like this. So now let me take a point in the second quadrant. The observer is exactly at this location only, same location. Then the point I am assuming in front of VP, not in front of VP, behind VP, because the observer is at this location. Observer position is not changed, so that the point is certain distance behind VP, certain distance above HP, certain distance behind VP, certain distance above HP. Then I'm rotating the HP to indicate the top view. So the front view of, then I am rotating HP to 90 degrees in clockwise direction, so that to see or to project the top view, to view the top view properly. So that I am going to indicate as A, point A, because the top view I am going to indicate A and front view as A double dash and side view A dash and side view as A double dash in this slideshow. Then let me take the same point in third quadrant like this. The point is behind VP and below HP. But here the point is above HP in front of VP. But here the point is behind VP above HP. But here the point is below HP then behind VP here. Now the point is exactly in the third quadrant. That point is A. Then the observer is exactly at the same location. Then the observer can see the point on the vertical plane like this. In front view will be A dash. Then I'm going to rotate HP in clockwise direction like this. This will become the top view. So when the point is in the third quadrant, the top view will come above the XY line. then front view will come below the XY line. When the observer is in the second quadrant, the front view and top view will come above the XY line. When the point is in the first quadrant, the front view will come above the XY line, top view will come below the XY line. When the point is in the second quadrant, the front and top view will come above the XY line. When the observer is in the third quadrant, top view will come above XY line, front view will come below the XY line like this. Then when the point is in the first quadrant like this, exactly like this, the point is in front of VP, below HP, then A dash will be projected on the vertical plane and A will be projected onto the HP like this. Then when the point is in the first quadrant, the front view and top view will come below XY line. This is vice versa to the second quadrant. In the second quadrant, when the point is in the second quadrant, the front view and top view will come above XY line. When the point is in the first quadrant, the front view and top view of the point will come below XY line. When the observer is in the first quadrant, when the point is in the first quadrant, the top view will come below XY line, front view will come above XY line. When the point is in the third quadrant, it is vice versa to the first quadrant. The top view will come above XY line, the front view will come below XY line, like this. This is how, when the point or a line or object is located in different coordinates, the views will come like that. Then let me move further to see projections of a point in the first quadrant. Then take the first quadrant and this will be our XY line. Then this is our point, and to this point is in front of VP above HP. That means this point is located at a certain distance from the vertical plane, at a certain distance from the horizontal plane, like this. Then this point is observed from the top like this, and this point is observed from the front like this. That means the observer is exactly perpendicular to the reference plane. When we see this object, in this case it is a point, when we observe this point from the top, the reference plane here is horizontal plane. Then when we see this point from the front, the reference plane is the vertical plane. That means the point is projected onto the vertical plane in front view. The point is projected onto the horizontal plane on the top view, like this. Then when I project this point, when the observer is perpendicular to the vertical plane like this, the point will be projected onto the vertical plane exactly. That is A dash. This will become front view. Then A will be projected. The point A will be projected onto the HP for the top view, and that needs to be indicated as A. Then this is A dash, front view will be A dash, that lies on vertical plane. Top view will be A, small a, which lies on the horizontal plane at a certain distance from the vertical plane. The front view is lying on HP at a certain distance from, the front view is lying on VP at a certain distance from HP. The top view is on HP at a certain distance from VP. That is what the distances are known to us. Then the point A is above HP and in front of VP is this case. Now the second case is the point A is above HP but lies on VP. we will take that example. Now the point is exactly lying in HP, lying in VP, but above HP. As you can see, this point is located at a certain distance from HP, but this point lies on VP like this. To this, if we want to project the projections, if we want to draw the projections, this will become our front view and this will become our top view, and this point itself will become A dash, and similarly this point exactly lies on the VP, so that that point itself will become A dash front view, and the point in this case exactly lies on the XY line when it is exactly lies on VP, and this will become A. That means the top view exactly lies on XY line when the point lies in vertical plane. Then we will take one more. When the point is exactly lies on HP but in front of VP like this, exactly the point is lying on HP but it is in front of VP like this. In this case, the front view lies on XY line, the front view lies on XY line, the top view lies exactly at that location itself. The front view A dash lies on XY line like this, the top view lies at that point itself, A, which is in front of VP. Here the point is above HP, lying on VP, but here the point is in front of VP, lying on HP. Now let us indicate the projections or draw the projections of these three cases. As I said, the horizontal plane will be rotated to the 90 degrees to view properly. So the point A, in first case, the point A is above HP. So above the front, that means the front view is above XY line. As you can see, the front view A dash is above XY line, that we need to represent. Then the top view A will be below XY line, that we are rotating HP, horizontal plane, to the 90 degrees to the XY line or from VP. So A dash, that means in this case, when the point is in front of VP, above HP, the front view lies above XY line, the top view lies below XY line. And similarly, when the point is above HP and lies on VP, in that case, the front view lies above XY line and top view lies on XY line like this. Then similarly, when the point lies on HP and in front of VP, in this case, the top view lies below XY line, front view lies on the XY line like this. These are the three cases that we come across while drawing the projections of the points. Then let me move further to see the projections of the straight lines. As of now, we have seen the projections of the points. When the point is in front of VP, in front of VP and above HP. When the point lies on VP, when the point lies on VP and above HP. When the point lies on HP, in front of VP. These three cases we have seen how to represent. In the first case, when the point is above HP and in front of VP, the front view lies above XY line, top view lies below XY line. And in the second case, when the point is above HP and lies on VP, the front view lies above XY line and top view lies on the XY line, a point that you can observe here. Then similarly, when the point lies on HP and in front of VP, in this case, the front view lies on XY line and top view lies below XY line. These are the three cases that we have seen as of now. Now, let me move further to see the projections of the lines. But here, the information required to project the lines on the planes is we require the length and its position. Position means up to what distance the line is located. The end points of the line is located with respect to HP and VP. That information we require. The first information is length we require, and the position of the end points of the lines also we require with respect to HP and VP, as well as we also require the inclination of the line with respect to HP and VP. Also, we require to project the line onto the planes. The basic information required to project, to draw the projections of the lines is its length and its position of the endpoints HP and VP with respect to HP and VP. Then the inclination of that line with respect to HP and VP is also required to project, to draw the projections of the straight lines. Then take some simple cases that we come across is a vertical line. That means vertical line means a line perpendicular to HP and parallel to VP. This is the case that we are going to come across to draw the projections of the line. That means in this case, the line is perpendicular to HP and parallel to VP. This is the vertical line. When we draw a vertical line, absolutely that vertical line is perpendicular to horizontal plane and parallel to vertical plane. And we may also come across a case that line parallel to both HP and VP. This is a horizontal line. This is absolutely a line parallel to both HP and VP. When we draw a horizontal line in first quadrant, that line is parallel to HP and VP. This case also we are going to come across in the projections of the lines. Then line inclined to HP and parallel to VP. Line inclined to HP. The line can be inclined to HP and parallel to VP. The line can be inclined to VP and parallel to HP. And similarly, line can be inclined to both HP and VP. These are the 5 cases that we come across generally in the case of projections of the lines. Each case we will discuss in the coming slides. Now, take one example. The first case. The first case is that a line perpendicular to HP and parallel to VP. This is our first case. Okay, the representation of that will be like this. As you can see, the first quadrant, I'm indicating, I have drawn a vertical line here. This vertical line is perpendicular to HP and parallel to VP. As you can observe, this line is parallel to VP and perpendicular to HP. Then the ends of this line I'm naming as A and B, and the observer is absolutely in front of VP. To locate or to draw the front view of this line, then the line will be projected exactly onto the vertical plane like this. With the length given, the points AB will become A dash and B dash like this with the true length of this line, A dash and B dash. And when you see this line from the top, it looks like a point which will be projected onto the horizontal plane as a point like this. That means the front view, when the line is perpendicular to HP and parallel to VP, the front view of this is a vertical line, the top view looks like a point that is projected on the HP like this. So this is exactly the pictorial representation. We will draw the actual notation after looking into the pictorial representation of the line when the line is parallel to HP and VP. In this case, when we see this line from the front, like this. It looks like a horizontal line on HP, exactly like this, horizontal line on vertical plane like this, and this will be indicated as A dash, B dash like this. And similarly, when we observe, when the observer, or when we want to draw the top view of this AB line, which is parallel to HP and VP, it is also a horizontal line on HP with the length, with the given length like this, and it is indicated with A and B like this. This will become top view, which is projected on HP, and this will become front view on vertical plane. And as I said with you, when the line is perpendicular to HP and parallel to VP, when we see the projections, orthographic projections, it looks like this. As I said, the line will be projected onto the vertical plane as a vertical line like this in front view. This will become A dash and B dash. In front view, this line is a vertical line projected onto the vertical plane. Then the top view of this line will become a point on the horizontal plane. Looks like, are projected onto the horizontal plane. It looks like a point as AB will coincide. A point and B point, A end and B end. The ends of these line will coincide at the same location, at the same point. So that is A, B. But here in front view, the point A, the end of A, line A will be A dash, the end of line AB, B will become B dash like this. And similarly, when you see a line parallel to HP and as well as VP, it looks like a horizontal line in both the cases. In the above XY line, in the uh, the the front view will come above XY line, that will be indicated as A dash B dash above XY line. Top view will come below XY line, that will be indicated as AB. Below XY line, the distance is that in front of HP, how much distance the line is located in front of HP, in front of VP, sorry, in front of VP, how much distance the line is located, that distance we need to indicate from the XY line. Then this line is located above XY line. How much distance this XY line is above HP. So that much distance this line will be located from XY line. And similarly in this case, how much distance this line is located in front of VP in the case of top view. So that much distance we need to indicate the point below XY line. And similarly, how much distance this line is above HP in the front view, that distance we need to maintain from XY line like this. Now, these two are the cases that we have seen. Then we will see the another case, third case, when the line is inclined to HP and parallel to VP. So this is the third case that I told with you in our previous slide. In this case, the line is parallel to VP, but whereas it is making some angle with HP. This line is making some angle with HP, but it is parallel to VP. And the ends of this line is capital A and capital B. The angle is theta. Now, the observer is exactly at this location. When we project this line as a front view, the front view will be projected onto the vertical plane like this with the given length and the angle. And that will become A dash and B dash. And similarly, when we want to project this line onto the horizontal plane, the A point will become here and the end A, the end B will come onto the HP. And the end A will come onto the HP at this location. The locations are A and B, and this will become your top view like this. This is at a certain distance from VP, and this is above HP like this. As you can see, so the AB line, A dash B dash line is making certain angle with horizontal, and it is having at a distance from HP, that distance we need to maintain here. This distance and this distance is same. And similarly, in the top view, we need to project these points and at a distance. So the distance is that in the top view, this AB line is at a certain distance from vertical plane. That distance we need to maintain here from the XY line. So this line is at a distance from the vertical plane. That distance we need to maintain in top view. And this is the orthographic, these are the orthographic projections of the line when it is making certain angle with HP and parallel to VP. And similarly, I'm taking one more case, that is when the line is making certain angle with VP and parallel to HP. This is the case that we have not seen. We will consider that case. The line is inclined to VP and parallel to HP like this. So as you can observe here, this line is making some angle with VP and this line is parallel to HP. Now the top view will be like this. The end A will come onto the HP and indicated as point E. The end of this line B will be projected onto the HP, that will be indicated as small b like this. The angle is theta. And similarly, the front view will be projected onto the vertical plane, that will be indicated. The ends of this line will be indicated as A dash and B dash. So this will become front view and this will become top view. And similarly, on the with respect to the XY line, first we have to draw the top view in this case, then in this case, the top view should be drawn with respect to XY line at a distance from the vertical plane. That means this line is located at a distance. The point A is at a distance from the vertical plane. So that distance we need to maintain. First, we need to indicate point A and draw a horizontal line, then indicate a point A on that. Then draw an inclined line, that is the given length, that is with the given length at a certain, with a given angle like this. So that will become our top view. Then project these points on the top, then project these 2 points on the top. Then at the distance specified, above the HP, this line is having located at a distance from HP. So that distance we need to maintain here. So this A dash B dash is located above HP line. That is what the given distance from HP. Then this project this point, and with a given height from HP, that distance we need to maintain. Then that will be indicated as A dash and B dash. Then similarly, we have another case when the line is inclined to both the cases. This is the fifth case that we have to see. This is the fifth case that we have not seen as of now. In the fifth case, the point is the line is inclined to both HP and VP. In both the case, the line is inclined to both the vertical and as well as horizontal planes. To this we have to draw the projections. This is our intention. Now, then the observer is observing here for the front view, and from the top view, he is exactly perpendicular to the HP, perpendicular to the VP. To draw the projections, because it is an orthographic projection, then this line is projected onto the VP like this with a given inclination angle, that is alpha, and that will be indicated as A dash and B dash. And front view AB with a given inclination angle, this is what AB, this line is making some angle with VP and this line is making certain angle with VP here, and this is with HP here. This is how the projections looks like. Then when we see exactly, this will become, this line is making some angle with VP, and this line is making some angle with HP like this. So, but when we draw this, just we need to indicate the angle with a given height. With a given height, indicate point A. Then with a given height, then draw a line that will intersect at this location. That will become B dash and A dash. And similarly, project this point here down. Then draw an inclined line with the horizontal, with a given beta angle, with the horizontal plane, Then this line will intersect at this location. That will become our point B, AB and A dash B dash. So these are the projections of the lines when it is inclined to both the planes. Then this is what we have seen already. So let me go back again. As of now, what we are covered. So I covered when the line is inclined to both HP and VP. In that case, we have to draw the projections of this line. So draw an inclined line on the vertical plane. Locate a point. Locate a point. So indicate that as A dash and draw an inclined line with a given angle with the vertical plane. So okay. So then, and similarly, draw a line which is inclined to the horizontal plane. Okay. So this will become alpha and beta like this. Then similarly, and when the line is inclined to HP and parallel to VP, we have seen inclined to HP and parallel to VP we have seen. So first we have to draw the top view, then we have to draw the front view with the projections. Then in the case when the line is inclined to VP and parallel to HP, in this case also, first we have to draw, in the third case, when the line is inclined to HP and parallel to VP, in this case we have to draw the front view first, then these points are projected to get the top view. But in the case when the line is inclined to VP, and parallel to HP, in that case we have to draw the top view first with a given inclination, draw the line, then project the points, indicate the points with a given length, then project the points to the front view. This is how we have to draw. When the line is inclined to VP and parallel to HP, in that case we are going to draw the top view first, then we will draw the front view. When the line is inclined to HP and parallel to VP, in that case front view will be drawn first, then top view will be later. So this is what we need to remember. Then in this case, when the line is perpendicular to HP and parallel to VP, so as usual we can draw the front view first with a given length, and up to what extent the line is located from HP, with that distance we need to draw the vertical line. It looks like a vertical line in front view and A dash B dash, and when we see this line from the top, it looks like a point on the HP plane, that will be AB. And similarly, when the line is parallel to HP and VP, it looks like a horizontal line in both front view and top view with the given distances, as you can see. Then these 3 cases are very, very important to draw while solving the problems. We come across these 5 cases in the lines. Then I have also covered a point A is above HP and in front of VP. These are the cases that we come across when the point is in front of VP and above HP. In this case, uh, the front view is above XY line and top view is below XY line. That is A dash will lie above XY line. A is going to lie. That means top view is going to lie below XY line. When the point is lying on VP, when the point is lying on VP and above HP, in that case, the front view will be above XY line and top view will be exactly lying on XY line like this. When the point is lying on HP and in front of VP, in that case, the front view exactly lies on XY line and top view lies below XY line like this. These are the 3 cases that we have seen, we are covered in this session. Then we have seen the representation of the points in different coordinates and how the point looks like this. That also we have seen in this session. Then the representation of the first, second, and third quadrant, how it looks like, that also we have seen. So in this session, we have covered all these different cases in the case of the projections of the points and in the case of projections of the lines. So thank you one and all. In the next session, we will solve the problems on the projections of the points and the projections of the lines. Thank you one and all.